especially most of this equation are empirical formula. Okay, empirical means they have lots of experimental data. Okay, so you cannot derive this. Okay, this is from experimental data. Okay, this value is from experimental data plus some theoretic, plus some theory of course. Okay, so next I'm gonna move on to the indoor air pollutions. Okay, if you remember in my first class, okay, in my first class, I mentioned the indoor air pollution is worse than outdoor air pollution. Okay, because there is a wind to blow away those pollutants, right? But if this room is still, okay, there's no wind in and out, right? So those pollutants will accumulate in this classroom. Okay? So, because the modern home, especially in North America, okay, especially in North America, they built more energy efficient, which means they want the room to be tightly sealed to reduce heat loss of the air condition, even the air condition loss, right? However, this gonna reduce air exchange between the indoor and outdoor. So as a result, the indoor pollutant will build up, will accumulate easily. Understand? So seconds, the detection and identifications can be difficult. So the indoor air pollutions, okay, the indoor air pollution often hard to detect. Okay, because many pollutants are invisible. Okay, and also not much stronger odors, and it might also come from many different sources. Secondary pollutant. I don't know if you still remember. What is secondary pollutant? What is secondary pollutant? We have primary and secondary, right? What does secondary pollutant mean? Sit down. Is Afi here? Afi, you didn't submit the homework.
I already emailed you.
I didn't receive your email.
And also I put it in comment.
Okay, talk to me after class.
Okay.
So, Afi, what is secondary pollutant?
It's like
Okay, secondary pollutant means, guys, if you remember, primary pollutant react with primary pollutant becomes secondary. Okay? Primary react with primary become secondary. Understand? Okay, secondary pollutant means the pollutants formed by chemical reactions. formed by chemical reactions. Okay? For example, like nuts. Nuts is primary pollutant. However, smoke is secondary. Right? Sauce is primary. However, acid rain is secondary. Okay, the salts during the hydration react with water becomes sulfuric acid or sulfurous acid. So this is acid rain. This is secondary. Okay, for example, like, I don't know, because in Taiwan, normally we don't use carpet. Okay, normally we don't use carpet. But in North America or Europe, okay, they normally they have carpet. Okay, they have carpet. Okay, and the gas of carpets, okay, is mixed with the chlorine dioxide. They got some smells. Okay, and also some in-home combustion, including a stove, heaters, and cigarettes. Okay, next slides. This word, carcinogenic means it will cause cancer. It will cause cancer. So the major contaminants, okay, is formaldehyde. Formaldehyde. Okay, this is common name. This IUPAC is methanolyl, air, not oil. Methanolyl, formaldehyde. This will cause cancer, so we call it carcinogen. Carcinogen. The radon gas. Okay, radon gas can enter from ground. Okay, so radon gas from ground. Radon gas from ground. This one is carcinogen as well. Okay, and also the radon gas is radioactive. So in particular cause, so it's strongly linked to lung cancer. The more mainstream. So the more exposures will cause allergy. Will cause allergy. So asbestos, okay, asbestos, okay, normally use insulations. Yeah. Insulation. The asbestos fibers now is considered carcinogens. It will cause lung cancer as well. Okay, and radiant gas again. Okay. The product in complete combustion, for example, like carbon monoxide. Okay, it's toxic. It's toxic. High level of carbon monoxide will cause death. Okay, pesticides. Some household pesticides. Okay, and some of them are non-carcinogens as well. Okay, second-hand tobacco smoke. Okay, will cause bronchitis and some lung disease. Okay? Okay? Okay, next slide showed you. Okay, next slide showed you the sources of indoor air pollution. Okay, so I think this is very great one. Okay, this is a great one. Even better than the one in the past week. Okay, so formaldehyde, the source like furnitures, right, and some stuffings. The spray is cancer. Okay. Irritate to eyes, throat, and skin. Radon 222. Okay. The source is radioactive soil. Okay. Lung cancer. Incomplete combustions, carbon monoxide. Okay, the source from furnace. But nowadays most people use electronic one. Okay, you will see a fire, but that's fire from LED. Okay, use electronic. Okay, so carbon monoxide. Okay. Asbestos, lung disease, lung cancer. Because you are going to inhale, suck in, okay, inhale, suck in those fibers. Okay. Nitrogen oxides. Okay. And some like chloroform and some toxic chemical. Okay, let's move on to next slide. Okay, you might take a look at this cartoon by yourself. Okay, really easy to understand. I think this one is better than the one in the past week. Okay, next one is the indoor air quality models. Okay, the formula again. Okay, so the V here is the volume of box. Okay, so what does box mean? The box means the indoor surface. Okay, and it's up. The box here means indoor surface. Indoor space, I'm sorry. Indoor space, the box. Okay? So C stands for concentration of pollutant. C stands for concentration of pollutant. And Q is the rates. Okay. Air flow, okay? Air flow rate. Okay, rate is very make this one easier. Air flow rate. Okay, is that easier? So this is airflow rate. Airflow rate into and out of the house. Out of the box means the space. Okay, and the CA stands for the concentration of pollutant in the outdoor air. Okay, this one you need to understand. And capital E is the emission rate, the indoor emission rate, the emission rate from the indoor space. And small the K, this is the decay rate. This is the decay rate. Okay, so you might also refer to figures 9-28. Okay, and if your question say a steady state means the concentration does not change. So if your question say at steady state, that means dC dt equals 0. Okay, the concentration does not change with time. We call this steady state. Okay. Okay, and this table give you the K value. The K value here. The decay rate for different chemicals, different molecules. Okay, for example, like carbon monoxide 0. And what is this about? Stone. I know you are good at organic chemistry. What is this? Ozone. What is this? Anyone to help him? Chen Soto. Soto chain. Because this is formaldehyde. Raise my back. 这是formaldehyde啊，写这样就看出来 ，right？ This is formaldehyde. Okay. So this table 9-16 give you the reaction rate coefficients. Okay. But selected pollutants. Okay. So the K here means the first order decay or removal. So the unit is the second. Is a second to the power minus 1. Okay, next slides. Okay, next slide is the emission constant, emission factor for the selected air pollutant source. Okay. So what is TVOC? So TVOC stands for total volatile organic compound. Okay. So, and also this table, and you also need to take the time into account. 1 hour, 1 day, 1 week, 1 month, 1 year. Okay. You also need to take the time into account. Okay? 时间要考虑。Okay, finally. Okay, so okay, finally, this is the general solutions. Okay, the general solutions. So this is this slide shows you the C stand for concentration. So this is concentration at time. T. Okay, this is a concentration at time T. Okay, so at steady states, dC dt equals 0, right? So we can get this. Okay? And if pollutant is not decayed, circle this, is not decayed. Pollutant is not decayed, that means K equals 0. The K equals 0. Not decayed. So if the pollutant is not decayed, then we can simplify from here to here. Understand? So that means the CT is proportional to E over Q. So E is the indoor emission rate. And Q is ventilation or airflow rate. Understand? So finally, we can come up with solutions. We can come up with solutions. The CT, so CT is indoor concentration at time. CT is the indoor concentration at time T. It's proportional to E over Q. Okay, that means the indoor concentration at time is proportional to indoor emission rate over ventilation. Okay, ventilation, or you might call this airflow rate. Okay, the meaning are the same. Okay, one more question. Okay, the question, in this question we are going to use those things. Okay. Okay, let's see these questions. Okay, just follow me. Okay, student, just follow me. An unvented kerosene heaters. Okay, this is some kind of chemical. Is operated for 1 hour. 1 hour. So we have T here. Okay, remember the T here, we need what? We need second. Right? We need second. So 1 hour, we need to convert this to 3,600 seconds. In an apartment. So this is indoor. Okay, because we are going to have the final exam is going to include outdoor and indoor, right? So during the exam you need to find out is this the indoor question or outdoor question? Because the outdoor and indoor will be different. So apartment, right? Okay, if you heard about a song, okay, apartment. Apartment means apartment in Korean. Okay. Apartment indoor. Having a volume, okay, 200. So we have B here. Okay. When I was your age, when I was a student, when I read over a question, I mark the thing I want, okay, the thing I need for the questions. Okay, the heater emits carbon dioxide. This is nothing. This is emotion. And the rates, okay, we got one thing. 50 micrograms. 50 micrograms. Emits. You see, emits here. It means sulfur dioxide doesn't mean anything. It means the rate. Okay, so what's this? This is E. This is emission. 50 microgram per second, right? The ambient air concentration is CA, and the initial indoor air concentration is C naught. Of the carbon dioxide is 100. So let me tell you, okay, the 100 is C naught, this is initial. C naught equal 100 microgram meter per second. So this 0 normally means initial. Okay, C naught here normally means initial. Of course, some textbooks use C1. Okay, some textbooks use C1, sometimes we use C naught. Okay, but let me tell you, initial. Okay, so we also got C now. Oh, also CA. So 100 is not just C now. This is also CA. So C naught and CA, both C naught and CA. Okay, either C naught or CA is 100. So if the rate of ventilation is 50 liter per second, so this is Q, ventilation, okay? They use ventilation, so actually this is airflow rates. So it's 50. So this is an airflow, so we use Q is 50 liter per second. But we do convert this. Because the question, in this question, we need, in these equations, okay, in this formula, we need to use meter cubic per second. So this will be converted to 0.05. Okay, this will be converted to 0.05. And the problem is assumed to be well mixed. What is the indoor concentration? So the question asks you indoor concentration. Okay, end of 1 hour. End of 1 hour. Oh, I'm sorry. Carbon dioxide is not useless. The carbon dioxide can give us what? K. Okay, the carbon dioxide can give us K. So let's go back to, okay, carbon dioxide. So the K is this. Okay? So carbon dioxide can give us K from table 9-16. So from table 9-16, it can give us K. So it's 6.939 times 10 to the power of minus 5 second to the unit, second to minus 1. All right? Okay. I'm gonna give you 2 minutes. I'm going to give 2 minutes to finish up those questions. Okay, I will give you everything. Okay, as I just mentioned, I will give you all the things. Okay, and you don't need to memorize formula. You just need to know which formula that you are going to use. And do you know how to use that formula? That's it, okay? I'm not going to ask you to derive formula.在环境工程，我们不会叫你推导，除非你是环工系。If you are the student in environmental engineering, maybe I will ask you to derive. Okay, but in this course, I will not ask you to derive. Okay. What I'm asking is how to apply it, how to use it. Okay, that's it. Okay, everyone, student, let's look at the blackboard, okay? So, this is the formula, okay? This is the formula I'm going to use, okay? 9 dash, okay, 9 dash. So the formula I'm going to use, okay, the formula I'm going to use is 9-16. Okay, and also from table 9-16, we can find out the decay rates or sulfur dioxide. This value. And also you need to do conversion. Okay? Then you plug in all the data. Okay, all the value. Okay, first off, you need to find out Q over V, right? Then you find out Q over V, you need to find out Q over V plus K. Okay? And Q, if you find out Q over V plus K, then you, why not times time? You can times time, right? Then next, you need to find out E over V. And also C naught times Q over V. Okay, so after you got all this, you plug in the formula. Okay, you will get. Okay, if the significant figures is considered, okay, you will show the answer like 630. Okay, am I okay? So this is the part discussion in the test paper. Okay, this is the some kind of question I might ask. This is some kind of question I might ask during our final exam. Understand? The question you find out today is something like this. Okay. All right, let's take a short break. Okay, let's take a short break. Okay, so let's have a break until 3 to 3:10. Okay.